Hello folks, Rashid here. Thank you so much for joining. Previous video was about the microarchitecture block diagram of what the load word. So we have load word, we have add I instructions both together, and I promise I will show you Python code. We will not do a detailed review. Actually, what I will start doing is in the description or in the comments, a few minutes after the video, I will post a link. You can click on it and you can take a look at the code yourself, and then you run it. The only thing is, if you go along with me, you will see the code there, which is more in line with my recent videos, right? But if you watch this after a week or two, then that code probably have a lot of stuff inside. Okay. I don't know how to do it, but I will. I mean, you're supposed to, you're supposed to follow me right now. But I think even if, for those who are new to my channel or who didn't get chance to watch those videos along with me, um, they can always look at the entire code and maybe just use the instruction that they have watched, and this is the best way. Well, this is my website. Okay. This app, this simulator that I built, right? Put here whatever instruction, add, let's say add I, and I put x5 x0 100, right? So what it does, the contents of x0, which is always 0, so basically it put 100 into x5, and after that you can also assemble and load. Okay, and what's happening? Step. Come on. Is this app alive? Run to end. Reset. Okay. This is dead. Let's reload this one. Always things happen. It was working totally fine. Okay, let's put this add I x10 x0 and we put 100 in it. Okay, good. Okay, it's on this website, so let it run. So my point is that you can put an instruction and you will get the assembly code of instruction, and then you come back here, and as I showed last time, I have two cells here. So first one is really the main code, and second one here, that it's a test bench. So all you have to do is put different instruction in that. The instruction that I just showed you, that instruction I put here, the 32-bit hexadecimal value, the other one here. So you can keep it one or two values or whichever way you want to analyze. You can always take this code, put it into Gemini, for example, or ChatGPT or Copilot, and try to understand. But I have kept things very simple, because I didn't create this code myself, but I did a lot of prompts there, and I've gone through the code myself just to make sure things are simple enough. So if you look at right now, last time that the code I showed was a little more software type, right? There were a lot of if else, but this time I have separated things. So if you look at, I now create a separate controller. Okay, inside it calls, okay, this is a class controller. Okay, inside there's a function decode, and it has these. Right now I'm creating these control signals at the time of this video. So the signals which are required for add I and load word instructions. So by default they're false. So write register file, write enable, right? ALU operation right now, for this instruction we gave it add, but right now it's not, which is the default value, and it's not doing anything. Memread, so this is memory read. Memory write, I don't know why memory read we needed, but that's okay. Right now it's working, but this probably you can look into, or maybe in future versions, if you in future versions I will remove this. Mem to reg, So this is the data coming from memory to register file on that multiplexer that I showed in the previous video. This is that one, and currently it was false. And ALU source, yes. So the source of ALU, it's there's also will be a mux there eventually. I think this is that. Ideally, I want to put this outside too. So I want to create my Python code very much matches to what I have in the block diagram that I showed you. Okay, so that later on I take that piece and I code this in system Verilog. That is really my intention. Things are not there yet, but I will improve them over time. But in this controller, you see if opcode is this, so the input that comes to this decode is opcode, the func3, right? Based on these, and self is always the instance of that controller. When this comes, it generates different values for those signals. And this is comes as a dictionary, and those are generated. So it good kind of models the controller. So I'll update this one, but I hope you get the point. Then we have RISC-V data path. This is initialized one. This is a reset we looked into previously. This is load program, which loads from the flash memory into the instruction memory. So printing of those, and this one I created just a kind of printing the value. So I wanted to print the actual hexadecimal value of the instruction. So I ask it to add that. And the hardware blocks, so you look at it, instruction memory block, I created a memory. Okay, an address comes in. Right now we're not writing or anything to it. This instruction memory, the moment address comes in, the value goes out. And this value instruction memory dictionary was already written. And decode block, right? Decode is you give it all these values into this, it returns this. It gets the instruction, right? And it returns all these. So things are a little bit more aligned, and I put ALU kind of like this. Later on, right now it has ALU operation add, and it does this one. Later on we will add more comparison and subtract and all those. Data memory I created with this. This is where that thing was. Okay, right now ideally whenever the address comes here, immediately we read the data. We don't need a mem read. We do need a mem write, which not this time, but we will do in the next instructions. But I think right now this is not needed, so probably this is redundant. I will be removing this. Sequential blocks, okay, now writing into data memory write clock. Okay, it did create that one. So if memory write is 1, then it is going to write into that address. Okay, register file write clock. So this one is write enable, and the address is not 0 because we don't want to write onto the X0 register. It always contains 0 values. All right, then this step function is, you can see that a little bit more aligned. It just has a connections there now. Okay, you see that? It doesn't have much logic in it. All the logic is inside those functions, which are really are hardware building blocks. So then, this is pretty similar. As I said, you put these two instructions. I put an add I just ran it, and you can see that initially I wrote something in this data memory location for my second instruction. So first instruction was PC0 add I x5 0x. So after this, x5 should contain 100, right? So then you fetch this one. So when that's instruction fetch, this is what that printing does. Remember the one I showed you. This hexadecimal comes, so it looks like it has identified it correctly. This is the same instruction that we put there, and it shows that okay, wrote 100 to x5. Then cycle 2 comes, which is load word, and it's at PC0 location, right? And this is the instruction, and you can see that read this from this. So at this address, the result was ALU result came there. This is the address, this value x5 plus a, and at that whatever data come was 777. Remember in the beginning I wrote that, and then eventually it wrote this into x10. And these are the register that update. X5 value we changed, X10 we changed, and PC is pointing to the next point. In this cycle, PC is always, it already gets the new value. All right, so the next instruction, if we have another instruction I put there, it will execute that one. So understand that? Yeah, did this came or not? I don't know what's going on. I will take a look. This is on this web page is on the GitHub. I need to update this website because I have started now. I just wanted to show you. Yeah, you can take a look. I will update this website in a day or two, but in case you don't know, always go there, and here is where I put all the series there, and architecture we did, and this is what I'm going to update the link of it. Okay. All right, that's it for now. Hope the things that I explained make sense, and if you have any questions, please let me know.